Okay, we're beginning a new chapter called Quadratic Functions and Equations, and we're going to start off by talking about quadratic graphs and their properties. So, first off, let's define what we're talking about, which is a quadratic function is a type of non-linear function that models certain situations where the rate of change is not constant. So what you should get most out of this sentence is what we've talked about. Nonlinear means that it's not going to be a line, because when we had a line, then our rate of change was constant. So now we're talking about something that's not going to be a line, and the rate of change will not be constant. Now, the graph of a quadratic function is a symmetric curve with a highest or lowest point corresponding to, highest is going to be the maximum value. There's too many curves on that M. The highest is a maximum value, and the lowest point would be the minimum value. Now, here's a picture of a quadratic function. It is the simplest quadratic function that we have, and so its equation would be y equals x squared, also written as f of x equals x squared, and it is called the quadratic parent function. Okay, it's the parent because it's the one that we're going to always refer back to. Okay, and the graph of a quadratic function is, hopefully you can tell by this graph what letter that looks like. Okay, so that's why we call it a U-shaped curve, and the fancy name for it is parabola. Now, if we make a table of values, we have y equals y or x squared, however you want to think about it. Okay, and I'm going to skip the 0, 0 point. I'm going to come back to it. But if you put in x is equal to 1, then 1 squared is 1. We've talked about that before. If x is equal to 2, then 2 squared is 4. If x is equal to 3, 3 squared is 9, so forth and so on. So you could keep going with those key points. And remember that the vertex is this point right here. It's the lowest point on our parabola, and you're going to see it in a minute in our picture. But it's either the lowest point or the highest point, and in our parent function, the vertex is 0, 0. So here are two different parabolas, one going up and one going down. Both of them are coming from a more general, or what we call the standard form of a quadratic function, y equals ax squared plus bx plus c, where a cannot be 0. Now, first off, let's talk about this graph. And what we notice, or what will cause that graph to happen, is if a is greater than 0, that means it will be a positive number. So in this equation, if a is positive, the parabola will open up. And that vertex point right here will be a minimum in my graph. All right, we talked about that it's a symmetric curve, so we refer to this dotted line as the axis of symmetry. This point right here is that lowest point, or the minimum point, and it is called the vertex because it's opening up. That's the minimum, as we just talked about. Now, in contrast to that, if a is less than 0, and we're talking about this a value here, in a standard form of our equation, then our parabola will open down, and the vertex will be a maximum point. So here again, our dotted line is still our axis of symmetry. And this point right here, this blue dot is again our vertex. But because our parabola is going down or opening down, then hopefully you can see that that's the highest point, also referred to as the maximum. So our vertex is a maximum if it opens down, and it's a minimum if it opens up. So what kind of questions do you need to be able to answer? You need to be able to look at a graph and tell me what the coordinates of the vertex is and tell me whether or not we have a minimum or a maximum. So if I look at this first one, my parabola is opening down. My vertex is the highest point. So we use the letter V, and we say that this is the point 0 because this is my origin. So I've gone left and right 0, but I've gone up 1, 2, 3. So this is the point 0, 3, and it is a max. It is the highest point on my graph. Look at the next one. Okay, we're looking at this point right here, and that the coordinates of the point, here's my origin, for O for origin, and so we have, from here, I've gone to the right 1 and down 1. So that is 1, negative 1. And if my parabola is going up, hopefully you can see that that is a minimum value of my graph. And here's another one. And we have, again, going up. Here's my vertex point. My vertex point is left 2 and down 3. So my vertex is going to be negative 2, negative 3, and it's going up, so I have a minimum. All right, another type of question that we're going to have to be able to do is to graph the function. They give me an equation, y equals negative 3x squared, and then answer what the domain and range are. So this is where our key points are going to come into play. First off, we have our table, x and y, and we have, these are what we're referring to as our key points. So my key points from that table that we filled in on the first page, okay, that's these values in case you're wondering. These values right here, these are my key points. So I'm going to put them in this vertical fashion. X is 1, you can go down 1, 2, 3. 1 squared is 1, 2 squared is 4, 3 squared is 9. All right, those are my key points. And what's going to happen is you're going to go find out what A is. So remember our standard equation was y equals ax squared plus bx plus c. We'll go find out what a is, so hopefully you can see right there that a is negative 3. So I'm going to write down a equals negative 3. And what you're going to do is that's going to change each of your y values. So my x values are going to stay 1, 2, 3. And now I need to multiply each of these by negative 3. So 1 times negative 3 is negative 3. 4 times negative 3 is negative 12. 9 times negative 3 is negative 27. So also, when you have just a simple form, this is very close to that parent function, there's no b or c in it, then your vertex will always be 0, 0. So my vertex is 0, 0, and the other thing we want to remember is our axis of symmetry, and that is x equal to 0. So from here, so let's go plot our vertex. Our vertex is at 0, 0, so we're plotting that point. Now, the next is your axis of symmetry, which is x equal to 0. It always goes through your vertex. It's a vertical line through your vertex. That one looks kind of big. Might have a hard time even finding my vertex there. So my vertex is at 0, 0. Now, this tells you what to do. This is what you go over, and this is what you go up or down. Up if it's positive, down if it's negative. So from 0, 0, if I go over 1, I'm going to go down 3. 1, 2, 3. All right. And if I go over 2, I'm going to go down 12. 1, 2, 3, 4, 5, 6, 7, 8. All right, it's way down there, so I'm not going to worry about it. Now watch what we do with our axis of symmetry. When you have a point on one side, you count back over to the axis of symmetry and count over the same number of units. So I went 1 to get there. I'm going to go 1 on the other side. Now, 2 on both of these got me way down here. So when you draw your graph, you don't want to go past the 2. So we're going to make it look like a curve. And that's a pretty bad looking curve, but you got the gist of it. And that's how we graph our parabola. Now, our domain. Domain is, these correspond to your x and y values. And just like in alphabetical order, D comes before R, X comes before Y. So what comes first goes together. We talked about this, but it's been a while. So your domain, and your domain says what values of X can I put in here, and every time for our parabolas, your domain is going to be all real numbers. So you can just write all reals. But our range, okay, remember this is a maximum value, okay, because my parabola is going down. So that means my y, the highest y value that you have is 0. So we write y is less than or equal to 0. And that's your domain and range. Now, I put 3 graphs on here, hoping that you can see the relationship between A and the opening of our graph. So look at this. I have, this one is negative 4x squared. This one is 1/4 x squared. And this one is just x squared. So what we're trying to notice and what you need to remember, first off, is the smaller a is, and let's go ahead and write, we're going to write absolute value, because that means it doesn't matter if it's positive or negative. Which is smaller between 4 and 1/4? Well, hopefully you know 1/4 because that's less than a whole. So the smaller it is, the smaller a is, the wider the opening. Okay, now we did say that that was the absolute value of a, because the other thing you need to realize is that we've kind of already talked about it. If a is positive, then it's going to open up, and if a is negative, then our parabola opens down. So from that, if you're given a set of equations, f of x equals negative x squared, 3x squared, or negative 1/3 x squared, and you have to do it from widest to narrowest, then you're going to go look and see the widest one will be the smallest a. So this is a 1, this is a 3, that's 1/3. So which one's the smallest is 1/3. So we write negative 1/3 x squared. And then the next one is going to be 1, which is going to be the negative x squared. And then the last one will be 3x squared. Because again, all we're doing is looking at the a. We're not looking at whether or not it's positive or negative. Okay, a few more problems and we'll be done. We have to graph y equals x squared and y equals x squared minus 3. So y equals x squared, we've already talked about. That's our key points, x and y. You should know that your vertex is at 0, 0. And my key points are 1, 2, 3, 1, 4, and 9. So I start with my vertex at 0, 0. I go over 1, I go up 1. If I go over 2, I'm going to go up 1, 2, 3, 4. So we have something like this. And do your best. You really want to connect them and try to make it pointed. I kind of missed my dots. Hope y'all can do better than that. Alright, and now we're going to go look at y equals x squared minus 3. And just for the sake to make sure you remember how to do this, and then we'll kind of generalize it, okay? Let's go plug in some points. Let's go plug in 0, 1, 2, 3. If you put 0 in, you get 0 squared, which is 0, minus 3, or negative 3. If you put in 1 squared is 1, minus 3 is negative 2. If you put in 2 squared is 4 minus 3 is 1, and 3, plug in 3 squared is 9, and 9 minus 3 is 6. So if I were to plot these points, then I would have 0, negative 3. I would have 1, negative 2. I would have 2, 1, and 3, 2, 4, and way up here. Okay? Now, the question is it symmetric? Is this my line? So let's go put in negative 1. And hopefully you'll see negative 1 squared is 1, and 1 minus 3 is negative 2. So I match this point on this side, which means this one will match. 1, 2, 1, 2. And we have our parabola looking like this. So how are they related? Hopefully you can see that when we put this number right here, that ended up moving my graph down 3 units. So they're exactly the same, except for this one has been moved down 3 units. All right, last problem, falling object model. We have an acorn that drops from a tree branch 70 feet above the ground. The function is h equals negative 16t squared plus 70, and it gives the height h of the acorn in feet after t seconds. What is the graph of this function, and about what time does the acorn hit the ground? So I started a table of values because if t stands for seconds, can I have negative seconds? And we can't have negative seconds, so we start at 0. When we plug in 0, my variable term is 0 plus 70, so I'm going to have 70. If you plug in 1, you're going to get 54. If you plug in 2, okay, and all I'm doing is 2 squared is 4. 4 times negative 16 is negative 64, and negative 64 plus 70. But I know y'all can put that in your calculator. And 3, when you plug in 3, you're going to end up with negative 74. So what I do is we're going to go plot these points. 0, 70. 0, 70. 1, 54. So we're just going to estimate where we think 54 is. 2, 6. Ooh, that's down here. And 3, there's no place to put that on my graph, but it's way down there. So if I connect those, because I could find the other points, but let's just do something of that sort to try to connect those. If I connect them, then you'll see that if I hit right here at 2, that's the point 26. So it obviously has to go past that. They want to know what time the acorn hits the ground. Well, hopefully you recognize that my graph starts at 0 and goes up to 70. So if it hits the ground, they want to know when is the height 0. And the height is 0 at this point in my graph. Right down there at the axis, which I'm just going to say shortly after 2 seconds. So it's just about reading the graph and understanding what the information is. All right, that is the end of the first section. If you understand, you can go start your assignment. If not, I will continue to work examples of each type. Okay, let's go look at some of the problems that you'll have to do. Very similar to what we just did. Remember, every time you work an assignment problem, this refers back to the example that we did together. But I have chosen a few more problems to do if you still want to see some more examples. So to start off with, number 8, identify the vertex of each parabola. Tell whether it is a minimum or a maximum. So I look at my parabola and identify the vertex. It's that lowest point on my parabola, lowest or highest point. It's going up. This starting at my origin is at 1, 2, 3, down 2. So that is the point. My vertex is at negative 3, comma, negative 2. And is it a min or a max? It is a minimum value. My parabola is going up, so it is the lowest point on my graph. And that's all you have to do for that. Now we have to graph this function. So let me move this down a little bit. Um, and when we do our graph, we're gonna look at our key points. So to look at our key points here, as we did before, what we did is we wrote down our key points, and that's the best way to learn them, okay? Our vertex is still 0, 0, because we have just an a value. And my key points were 1, 2, 3, 1, 4, 9. So on my graph, actually, I'll go put some axes first. We talked about what A is, and A is equal to negative 1/2. So that means that I'm going to take each y value and multiply it by negative 1/2. So I have 1, 2, 3, and 1 times negative 1/2 is negative 1/2. 4 times negative 1/2 is negative 2. And 9 times negative 1/2 is negative 9/2. Or if you're using a calculator, that might give you negative 4.5. Okay, so we're going to go plot. We plot our vertex. It is at 0, 0. And if I go over 1, remember this is my over, and these are all negative, so I'm actually going down. So if I go over 1, I'm going to go down 1/2. If I go over 2, I'm going to go down 2. And if I go over 3, I'm going to go down 1, 2, 3, 4.5. And then each of those points, again, remember my axis of symmetry goes through that vertex. So I'll go ahead and put that. I'm going to see if I can get a skinnier version. I'll have this style. Let's see if that doesn't work. Okay, a skinnier version is going to, nope, I don't think that's much skinnier, but that's fine. You got the idea. So there's my vertex, and I'm going to count over. This is at the 1/2. So I count over 1 to my axis of symmetry, over 1 to the other side. Count 1, 2 to my axis, 1, 2 to the other side. I go to this point. 1, 2, 3, 1, 2, 3. And then I do my best to connect them to look like a curve. You do not want it to be pointed. I kind of missed that. Let's try that one again. And there is my parabola, y equals negative 1/2 x squared. They want us to give a domain. Our domain we talked about for all of our parabolas is all reals. And my range, okay, very similar to the example we did. The highest point is 0, and it's less than or equal to 0. If it was going up, it would be greater than or equal to 0. Okay, next group of problems says order these from widest to narrowest, And remember, wide means that a is going to be really small, so we're looking for the smallest number. So of the a values, this says a is 3, this says a is 2, this says a is 4. So the smallest one, of course, is 2. So we have y equals 2x squared. Then we go to 3, and then we go to 4. And that is put our graphs in order from widest to narrowest. Okay, the last example that I picked was to graph another parabola. I think I had this down here. Let's go down. Oopsie. Wrong ending on that one. Who did that? Alright, so let's put my axis back. Alright, again, we're going to do our table of values, but one of the things I want to point out, this is our C. Okay? And I don't have the right thing on there. This is my C value. Okay? So, go into my key points. This is X and Y. My vertex point was, when we did this before, in our example, we figured out that our vertex point was usually at 0, 0, but when I put in 0 here, and I add 4 to it. So my vertex is now 0, 4. And then I have my key points 1, 2, 3, 1, 4, 9, because they're only going to change if I have an A value. So again, this is my over, this is my up. So starting at 0, 4, 0, 1, 2, 3, 4. If I go over 1, I'm going to go up 1. If I go over 2, I'm going to go up 4. Okay? And that's enough. If I go over 3, I'm off my graph. Find each point and go back to your axis of symmetry. Because remember, the axis of symmetry is that vertical line through your vertex. So I'm counting back over 1, over 1. Take this point. 1, 2, 1, 2. And that's all we need to get our graph. And I totally missed those points. Let me try that one more time. Alright, this will be the last time, and then we're going to end our lesson on quadratic functions and their properties. And that one's actually pretty good. So that sums up our lesson.